Welcome to everyone's favourite segment, Mailbag.
Mailbag, Huckster, yeah. Little Huxley's joining me, aren't you, Hux? School holidays. And how old are you, Huxley?
4 years old.
4 years old, and you're turning 5 soon, yeah?
Yeah.
All right.
I'm nearly 5.
Nearly 5. Cool. You want to open some packages?
Yep.
Yep, okay, excellent. All right, not that one, not those ones yet, because I kind of have one already opened. So, yeah, sorry, spoiler. Check it out, it's a new Siglent bit of kit. Thank you very much, Siglent. It wasn't addressed to Mailbag, it was just addressed to here. That's an oscilloscope, isn't it, Huxley?
Yeah.
Yeah, cool. Does that look good?
Yeah.
Yeah?
It has an on button. What does the on button do?
Well, it switches it on. And it doesn't have separate vertical channels though, unfortunately. It's only got one vertical channel for all 4 because the screen is so huge that they couldn't fit all of the knobs for each channel. So we'll switch that on later, yeah? Does that look cool?
Yeah.
Yeah? Anyway, that is the SDS 2354X for the Plus. The 54X, it's the X Plus series, so it's the 2000X Plus series. I believe it's their 3rd generation 2000 series. Not to be confused with the 2000, the 2000X. This is the 2000X Plus. Anyway, future videos coming on that. Let me know if you want a teardown or not. And they sent a whole bunch of other stuff. Thank you very much, Siglent. Nice little carry bag. Who's that? I don't know. Is that just a model, or is that somebody, is that an engineer at, that could be an engineer at Siglent? Given the OK hand symbol.
A bag.
A bag. Would you like that bag, Huxley?
Oh, yeah.
Yeah, you want to put things in it? Yeah? Okay, well, we'll save that. And we have, what else do we have? We have a t-shirt, a Siglent t-shirt. That looks enormous.
Well, that would look awesome for Daddy.
That'll look awesome for Daddy, you think. It's got Siglent on it. What size is that? 6XL. Just a tad. It's American. Yeah, I'm like small or medium at most. But yep, there you go. 6XL. Maybe I can find somebody who likes a 6XL. All right, what else have we got? We've got like a whole bunch of these mystery boxes. And that's the good thing about Mailbag, Huxley. You never know what's going to be in here. So we have 5 of these. Let's go. You want to open that?
Yep.
Okay. It looks like you've got to slide it out. Wow, it's hidden inside. What do we got? What's that? Whoa. Whoa, hello. That is a Weir screwdriver set.
Cool.
Wow, cool. Let's have a look. Thank you very much, Siglent. Whoa, that's in a, hang on. There are Siglent branded merch. So Siglent brand, nice merch, nice choice. Oh, hang on, look. It slides out like that. Oh, look at that. Oh, isn't that fantastic, Huxley? Look.
And another one.
It's a awesome little compact Weir screwdriver kit. That's absolutely fantastic.
Daddy,
yeah.
Another one.
Another one? How many have we got? Is it the same one? Same one? I might have to give them away. They trying to clear out their merch, are they? That looks identical to me. So, yep, I think we... Wait, have we got 5 identical ones? Take that one out, Hux. There you go. Is that the same?
Again.
Again?
Are you serious?
I think they're serious. I think we've got 5 Weir screwdriver sets. So I'm going to keep one for myself, and I'll probably give the rest away because I don't need 5 Weir. Yep. There you go.
Another one.
Another one. That's crazy, dude.
That's awesome.
That's awesome, is it, Hux?
Okay, so you'll get the next thing in the box.
Get the next thing in the bottom. Oh, yeah, there is something down in the bottom. Oh, that's just the, yeah, because they came in 2 separate boxes. That's just the probes and stuff. So, yep. Anyway, thank you very much, Siglet. So we'll have a look at the 5000X. Probably do a teardown of that thing first. I don't know if anyone's done a teardown of that. All right, Hux. There you go. Wow, 5 Weir screwdriver sets.
That is awesome.
All right, Hux, you want to open the big one?
Yep.
Yep. With the Weir kits, I think I'll give those away to my patron supporters over on Patreon. So, yep, thank you very much. Join me on Patreon, by the way. It's now linked in to my Discord server, by the way. The exclusive EEVblog Discord server. So if you join me on Patreon, you get access to the Discord server. If you're into Discord. But a lot of people are, apparently. I connected it, and all of a sudden 500 patrons or something went through, already were actually connected through the Discord. So a lot of people use Discord. Discord, not discourse. There's talk on the EEVblog forum about discourse. Let's not go there. Mailbag, it's from Shenzhen Zhangyi Technology Co. I have no idea. Sorry, thank you very much. What do we got? This is, what's that, Hux? Can you read any of those words? Yeah.
But if we just take that away, it'll be used.
Oh, good word. Yeah, user. If you take away the R, it's use. That's correct.
But you.
USER, that's user. User manual of Laser Master Laser Engraver. We have a laser engraver, Huxley. Let's open it up and have a look. Wow, there's so many things in here. This is probably, I'm not sure if this is something we can assemble for the mailbag. So I'll just leave that. Anyway, it's a laser engraver. There you go. Thank you very much. So it's one of those, it's just like an XY. So we have like an XY platform, Huxley.
Daddy, can I have a turn with the thingy to open it?
Sure.
Thank you. Oh.
That's part of the platform. That's acrylic on the end. So we've got acrylic on the end and then an extruded aluminium bar across there. And it's a laser engraver. Cool. So we'll have to assemble that. And here's what you get in the box with this thing. You can get the main, I guess we'll call that the Y-axis, shall we? Because it's Y on the video here. And that just fixed into place, of course. You can just sit this thing on a desktop like this. You don't actually have to mount it on a base. In fact, it comes with these little rubber baby buggy bumpers to just sit down like that. And then we have the X-axis arm, which will sit and screw on there like that. Well, it's the alignment of the bolts in there is a bit how you're doing, but that'll go on. So then that just pulls in the X-axis like that with the stepper motor here, and then we've got our laser module. There it is. Yeah, from the finest One Hung Lo factory, 15 watt laser diode. I have heard that it's not 15 watts, so yeah, marketing. Class 4, so I haven't actually measured it myself, but anyway, there's a laser diode goodness. Not, of course, good enough to probably to cut really any like major materials, at least to any thickness, but it's not designed. It's not a laser cutter, it's a laser engraver. So anyway, that will screw onto there, into these 2 holes there. So it's all really simple. There's very few pieces with it. You just get a couple of brackets and screws and other stuff. That's it. You get some laser googlies, and I got a fair dinkum Oscilloscope adapter. Not compliant because it doesn't have the insulation on the pins, but fit. And we've got the user manual from Dongguang Otur Intelligent Technologies Co. Limited. Assembly procedure. Just, there you go, a couple of bolts into there. Looks laser master, oh no, laser, what? 7 watts, especially good at picture engraving, 15 watts, available for both engraving and cutting. Yeah, well, I've heard that it doesn't do that, not to be used by kiddies under 14. Mrs. EEVblog would say that, well, I'm not allowed to use it then. So anyway, yeah, just put a couple of nuts on and Bob's your uncle. Yep, that's it. Couple of flat washers. No wuckers. And it looks like you just download the Laser Gerbils program and install that, and well, that's it. USB interface should work, presumably. Then you can just load in your images and engrave. That's the plan. Any sort of calibration, laser focus, yeah, I think you'd have to do some focus adjustment, something like that, but oh, that's all she wrote. There's not much to it. And on the bottom side there, you can see that it's got a little micro switch end stopper so it can home the thing. And is there a matching one up here? Don't think so. Just slam shut against that. Okay, assembly finished. Please put this laser engraver in a fireproofing area to give the first test. Confidence is not high. I repeat, confidence is not high. They really, really want you to know that it's CE marked. It doesn't have the correct lined up CE, but yeah, whatever. Anyway, there you go, DC input and USB. Shame it can't be powered from the USB, of course. You could have powered it from USB-C, for example. That would have been really nice. But unfortunately, yeah, it requires a separate DC adapter. All right, I've got my green lasery googles on and everything looks Matrix-like. It's black and white with a slight green tinge. I'll see if I can put these in front for you. There you go, check that out. That's what I'm seeing. Anyway, let's plug it in. I haven't got a PC yet. Yeah, it's got a couple of unlabeled buttons. There we go. She homes it. Yep, no wuckers. And I've downloaded the software as, I don't know, as dubious as it may be. It's an exe. You've got it on an isolated machine. Never trusted. And I just loaded in an example. You can just load in like a JPEG, a raster, like a image file. And yeah, I am certainly no expert on laser printers, so I have absolutely no idea what I'm doing. I just want to see that it actually turns the laser on and burns something, I guess. So yeah, I got no clue. And there we go, we can do a line preview on that to see what it's going to look like with our 3 lines per millimetre. That's alright, nothing wrong with that. Good enough for Australia. Don't know what the total size of that is though. Doesn't give dimensions. And just go next and auto size, there we go. We can set our size 100, I assume that's millimetres. I want it like absolutely tiny, so I'll go like, I don't know, 20 millimetres by 20. Because I don't have any fume extraction here in the lab. Not like proper fume extraction, so don't know what M3 or M4 laser is. Laser, I've no idea what any of that is. Create. Okay, we've got some sort of weird preview there. Is it processing something? I don't know what it's doing. No idea. Anyway, it does actually connect at 921,600. It connects at the maximum. So yeah, it's all connected. It's talking. I can get it to reset and do stuff. Well, I'll tell you what, the problem is I don't have extra icons here that it shows here. And one of them is the icon to actually calibrate this thing to like do the focus adjust where it outputs a really low power version of laser and you can adjust the dot size. Anyway, like I'm missing all of those. Missing all of those buttons. I don't know. I have updated to the latest version. I've got no idea. And it's not letting me do anything in here at all except like operate the menus and do a new thing. I can't click absolutely anything. I can't manually do anything. I don't know. All right, so what I did is I reinstalled the original one, which is exactly the same version in the manual 3.018, and I didn't upgrade. It tells you when you start that, there's a later version. Do you want to upgrade? I did that last time. Didn't do that this time, so I don't know. Now I can press the home in button and it does its little business here. So, it's all communicated. It's doing everything, but like where's the button to actually do what I want? Anyway, now I do have, oh yeah, manual control. Look at that. There we go. And you can it's actually sending the commands here. You can see the gerbil commands it's sending. There you go. So everything's hunky-dory. Sweet. And then I can home that, so it's all doing as requested. Well, oops, I finally figured it out. I pressed this play button up the top, and yeah, I burnt my mat. Wah, 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 wah. I should have put something under there. Oh, there we go. Yeah, oops, screwed the pooch. It works. All right, so I'm going to run this without calibrating anything. I'm going to try and get my fume extractor near it. And so just give it a whirl. So this is not configured, not calibrated, not anything. I've got my laser googlies on. Laser gerbils program, here we go. There we go. Aha, you can see it raster scanning. Cool. And that's really quick. Done. Sweet. So yeah, I know this is like a terrible example. It's not calibrated, not anything, but it did ultimately do something there because you've got to set the laser output power and how long it takes, you know, millimeters per second based on the material and all sorts of things. You've got to calibrate the spot size. It seems like a reasonable spot size, and then you've got to, like, you know, tweak the software for the preview. So that is equivalent to that, because that's like it's poorly rasterized there. So yeah, look, I have no idea what I'm doing. But anyway, you can see that it works, and that took 14 seconds. There's all the G codes that it sent to it, and yeah, it works. So yeah, I'm not sure why I was getting like no control before. Maybe it was the version or something like that. And I'm not sure why all the icons don't match the manual. I mean, the manual, like, how do I calibrate the thing? Like, it's supposed to have all the calibrate options not there and stuff like that. So I'm not going to spend any more time on this for the mailbag, but it obviously works. So there's the Otur laser engraver. I don't think it's a laser cutter. I don't think this thing's powerful enough. I don't think it's actually meeting its 15 watts, but that's just what I've heard from other reviewers. Look, I'm not an expert laser printer reviewer, but anyway, yeah, it's cheap and chips. It's simple. It takes like a minute to assemble this thing, and it kind of sorta works out of the box. Yeah, it's just a matter of dummy Dave actually using the software and figuring out the laser gerbils program. So if you want a cheap and cheerful laser engraver that doesn't actually take up a lot of room, then, you know, it might be okay. Check it out. I'll link it in down below. Thanks for Otur to sending that in. And yes, please, I'm sure there'll be no shortage of people down in the comments telling me how dumb I am and I can't use the laser gerbils program and all that sort of stuff. So anyway, yeah, I've now got a laser engraver. Yeah, just need to tweak things, and you do need fume extraction. I have got in the mail, literally in the mailbag, like a large fume extractor with the you know, the bendy Will Robinson arm things on it. So you'll no doubt see that in an upcoming video. Anyway, there you go. Links down below. It's cheap as chips.
Wait, who's it from?
Oh, who's it from? Good work, Huxley. Who's it from? It's from Kev Robinson in Dublin, Ireland. Hi to all my viewers in Dublin, Ireland. So you have to do the same thing and get under there. Okay, so cut away from you. Yeah, extend the blade out, cut away, and slice. There you go. Good work. There you go. You can open it up. What is it? What's that?
Calculator.
It's a calculator. It's a Sharp, for all you Sharp fanboys, EL505. You know we like vintage calculators.
Daddy, look, another thing.
Another thing? That's a note. What's that?
Under here.
It's like Christmas time, isn't it, Huxley? Wow, it's a book, is it?
What?
Wow, awesome. Practical audio electronics, Huxley. Like that. The Ford Press Book. That's all about audio electronics design. Ooh, that looks pretty nifty. Ooh.
It does look pretty nifty.
What does Kev say on his note? Let's have a look. The Sharp LZ mate. Am I pronouncing that? ELSI? This was my calculator through secondary school in the 1980s. When the exponent hit 99, it's able to shift the decimal point to give it a little extra range. Really? My maths teacher had a calculation designed to overflow our calculator, so we had to work longhand, but we had to update this example after my calculator failed to fall over on cue. Ah, wow, that's a vintage 1980s calculator, Huxley.
Now look, it's instructions how to use it. Yeah.
Aha, you found it. Does it work? It works.
Wait.
It works, Huxley.
It can do a plus. No, what's this?
That's trigonometry. You haven't learned trigonometry yet, Huxley. That's a bit advanced. You don't learn that in kindy. You won't learn those until probably high school. Does it get a thumbs up or a thumbs down? What do you think? You've got to give us a rating. Thumbs up! It's a thumbs up from the Huckster. Yeah. Oh, yeah, Kev Robinson. This is Kev's first book, an introductory electronics text, practical audio electronics. As the name suggests, it has an audio slant, but I think it serves pretty well as a general introduction. That's why I saw breadboards in here. I was wondering why there would be like breadboard stuff inside here. Let's have a squiz, a practical audio electronics. So an audio slant, but in general, electronics introductory book. Awesome. Well done, Kev. A lot of work's gone into that. Let us know, Kev, in the comments down below, how long did it take you to write that? Like it's probably like years of work. Wow, fantastic. And there's the Sharp Elsie, mate. EL505, hands up if you're a Sharp fanboy, or you had one of these back in the day. Look at that. 5-digit Mantissa, 2-digit exponent, none of that 8-digit Mantissa rubbish. Auto power off, fantastic. And big clunkin' on-off switch. Look at that. Beautiful. It's got your stat stuff as well. It's all happening. Love the little raised metal bit there. I wonder what that's for. Is that just pure aesthetic wankery? Let's crack it open. Couple of double A's. Not enough products have their power consumption on anymore. Look at this. None of this milliwatts or microwatts rubbish. 0.0005 watts. Fantastic. 500 microwatts for those playing along at home. And made in Japan. All the best stuff's made in Japan. Old school PCB. Check it out. Double-sided jobby too. Wow, spared no expense. Individual wiring coming from, and look at that, separate PCB in there just for the switch and to switch the battery power. Wow, wowza, wowza. And it's got these metal backing plates to give you a stiffy. Look at this. Can't have a limp dick calculator. Ta-da, there you go. NEC jobby. That's about all she wrote. Not much else on there, but that's it. Yeah, double-sided PCB, not the highest quality fiberglass. And they had to give it a stiffy bar too, because that is the contact that holds down the membrane keypad connection. Oh, geez. None of that conductive adhesive rubbish. Those tab connections, forget it. Metal plate and screws, thank you very much. So Kev's written and published a book. Awesome work. I can testify it takes a lot of work to write and publish a book, let alone an electronics textbook like this. So let's have a squiz. Practical audio electronics. But as Kev said, it's applicable to just general electronics use as well. Published by the Focal Press here, and Kev's a degree qualified electronics engineer, diplomas in electronics, music and sound, and he's taught degree level sound engineering courses and diplomas and stuff like that. Pegasus, the flying pig, love it. Anyway, you can send Kev an email at pigsmayfly@ircom.net. So I'll just give you a brief flick through. Let's have a look. Key concepts: electric charge, static, current good. There's no atoms and rubbish like that. Straight edge, yeah, AC, voltage resistance. Will we get the water analogy, conductors and pure silicon? Then we get into, diodes. Mains electricity and electrical safety. I like that. Obviously getting practical right up front. Then we get into time domain. It's an eclectic mix. Before you get into components. There you go. Because this is practical electronics. This is more electrical theory. So Kev's deemed that the electrical theory you need to go, but your basic concepts, of course, your semiconductors, your main safety, because you've got to build stuff, and signal characteristics and measurement and stuff like that. And then gets into components, vacuum tubes, for all you tube aficionados, circuit diagrams, electronic lab equipment, goes through scopes, 5 pages on scopes by the looks of it, basic circuit analysis, we've got Kirchhoff's, and constructing stuff, actually doing some projects, audio ones as well by the looks of it, and then component reference. Oh, geez, it's like half. You get into all your nitty-gritty stuff. Neat. And of course, tubes are in here because, they're still a thing in the audio field. Then appendices. Learn by doing. That gets a thumbs up from me. Introduction, practical electronics, electrical theory, learn by doing. Let's have a quick squiz. Key concept, don't want to give away the whole book, but got to have a quick squiz. Yep, the water analogy, called it. Electric charge, so static and static and current electricity, static electricity, things like that. Anti-static wrist strap, yep, that battery and the circuits. And, straight into waveforms. Direct current, AC, although I'm not sure that, it's not explaining what the axes are there, I guess. But anyway, we've got voltage, resistance, speakers, magnetism, conductors and insulators, resistivity, all that sort of jazz. Yep, that's all right. Pure silicon. Yep, yeah, well, we've got basically to understand your junction, then you've got to do a page on atoms and stuff like that. Yep. Transistors, all the different types. There you go. I like that little tree there. That's pretty good. PN junction types. It doesn't get into characteristic curves and stuff at this stage, but there's no simple schematics associated with the theory here, so maybe that will come later in depth. All those weird ass plugs. Mains power distribution. I like the look of that. That's good. Goes into volts peak to peak. So that's all practical mains stuff and safety and things like that. Neat. I'm talking about sine wave, distortion, average RMS, signal wavelengths, all that sort of, all your requisite formulas. Oh, no, neat. It's well laid out. Practical. Passive components. Oh, I've gone for through hole. I guess one criticism I would have is that, it should have, because modern electronics is, mostly all surface mount, I would have had a whole bunch of different types there, electrolytics and then SMD ceramics and stuff like that, SMD resistors and other inductories and things like that. Anyway, there you go. Photo trannies, chippity doodahs. But as a basic level, that's neat. Block diagrams are typical system block diagrams and stuff like that. So this is getting into how to read schematics and stuff like that. See, it's jumped straight into this, but we didn't actually look at, I don't think we've looked at until now, the schematic symbol for a transistor, for example. So it's maybe a bit out of order perhaps, but we can get that further on. And breadboards, how to wire up breadboards. So real practical stuff. Neat. A more elaborate example, there you go. We've got some sort of, it's a noise gate. Then lab equipment, power supply, old school linear power supply. Great stuff. Old school function gen with the buttons, the Vichy multimeters. The Micronta analog VOM. Get into our crows, as we call them here. Not a huge amount on scopes though. But enough, I'm sure. Basic circuit analysis. Then you get into your Ohm's laws and your transistor symbols. Here we go. Here's we get into our practical symbols and stuff like that. So you could argue maybe a bit out of order, but maybe there's a reason for that because I haven't sat down. I'm just flicking through this thing. We've got our resistor color codes. No, this is not a color printed book. Hence, there's no color in here. It's a black and white printed book, but that's cool and groovy. And, pots and tapers and things like that. Nice. Capacitors and inductors. Then we get into our impedance stuff and things like that. This is pretty good. Once again, there is no perfect one text. I've done reviews of electrical textbooks before. No such thing as the perfect textbook. Everyone's different. Everyone learns different. Highly recommend you just have many different types and whatever clicks with you is the one to, all your different symbols for your trannies. Fantastic. So a lot of work's gone into that. Good on you, Kev. I actually rather like that. That's quite good. That's well worth looking at. I'll whack a link in down below if you're after a sort of an introductory electronics text with a practical and perhaps audio bent to it. On you, Kev. Huxley wants to hit this button, don't you, Hux? Wah, wah, wah. It's a fail button.
Daddy, I've seen one of those noises before.
You have heard that noise before?
Yeah, but it's on the computer in Math Seeds.
In Math Seeds, is it?
Yes, it's when you lose some of your skills. You've got that noise.
Right, yeah, because that means that, when you fail or lose something, that's the sound. Wah, wah, wah. Okay, you want to open another one?
Yeah.
It's already opened because silly me didn't see Mailbag on it, so have a look in there.
Ooh.
Oh, who's it from? It doesn't say. Dave's Deals. Thank you very much, Dave, I guess, from Dave's Deals.
Let's get it out. Aha! I made a hole. It's only a 5, 5.
5?
5.
5, 5, 5?
5, 5, 5. Sticker fun spaceships.
Sticker fun spaceships.
And it's 5, 5, 5.
It's a 555, Huxley. I'm not wearing my 555 timer t-shirt. I'm wearing my flux capacitor t-shirt. Available down below on my merch store. Yeah, my hand drawn. It's a 555 timer, Huxley.
Whoa.
That's awesome, isn't it?
Let's take a look in it.
Let's take a look. It's a sticker fun intergalactic space station. Where's our stickers? I assume they're in the back, are they? Alien threat. So we've got to stick them. Alien attack. Hang on. Yep. There's our stickers. Oh wow! Look at them. You got all little spacemen.
Oh,
And what else? All sorts of stuff. It looks like you can actually construct things with the stickers. This looks pretty good. That's the 555 sticker fun spaceship. Thank you very much. I don't know. It came from Dave's Deals here in Castle Hill, just practically next door to here. So I assume Dave's Deals is just a book store, and somebody has sent me this. So thank you. Some unnamed person has sent this. Thank you very much. That's very cool. Although obviously it's got nothing to do with the 555 timer, so whoever wrote this obviously had no idea about the 555 timer. But anyway, it's 555 timer sticker fun spaceship. Awesome.
Next box.
Next box. Oritech. There's the second suck of the mailbag, Sav. We've got a note and some stickers.
Daddy,
A
look!
little bit. Oh, what is it?
It's a
Look, and he's not quite sure what it is. It's a thing. Let's get excited.
It's a thing. I know a thing.
Increase battery life of your devices and apps. It's an Otti all-in-one hardware and software tool for energy optimization. Oh, okay. It's a power meter thingy. It's an energy optimization power logger something or other. Let's take a look. It's from the Quitech team. We saw a few discussions in your forum about Otti, so we thought you might be interested in forming your own opinion on it. Hope you have a great use of Otti. Looking forward to more topics on energy optimization and long battery life in your channels. It is really needed in the communities. Thank you very much. The Quitech? Do you think it's Quitech or Quitech? Quitech. Good one, Hux. Thank you very much to the Quitech team. I'm sure I'm not pronouncing that correctly. Anyway, all-in-one hardware and software tool for energy optimization for measuring current. Looks very simple. Let's crack it open. All right, what do we get? Oops. Don't want to show you the activation code. And, oh, look at that. Oh, beautiful. Nice fancy box. We've got a USB cable. It just plugs in. And that's all she wrote. Max 5 volts, so yeah, it's only for low power electronics. You don't want to, accidentally overload the thing. I'm sure it has some sort of protection in there, and it's got some GPIO and stuff like that, which is nice if you want to sync stuff up. Looks like external ADC and sense as well. That's terrific. Like if you're running your own external shunt or something like that, current shunt or something like that perhaps, or measuring the voltage, because this is probably, I don't know, is this the current shunt or is the sense, I don't know. RTFM, Dave. I assume it can be powered through the USB because all they've provided is a USB cable, so optional DC in. Oh, I think this is used to power your device. So the current shunt and voltage measurement is going to be internal, but as I said, you can get external because it looks like, just connect it up to your computer and then connect your Internet of Things doodad up to the output port. So, does it, I guess you can program the output voltage, 3.3, maybe 5? Something like that. In that case, maybe that's what that's for, is to power. Maybe not all of it comes from the USB. I don't know. Online manual. Oh, it's just all around. Oh, This feels beautiful. Anyway, there's a couple of heatsink screws in there. I've taken off the back plate. So now that should just slide out. Ah, beautiful. Well, the first thing that strikes you is check out all the holes they've drilled in there. Look at that. Well, I guess that's one way to do your isolation. There's just a couple of tracks coming out of there. You can see, you know, just poking their head out there like that. But there's a label on here which says that production test fixture hole, don't remove. So yeah, they've got like a pins, maybe, you know, going to opposite corners, and yeah, that's the production bit of nails. Anyway, it's upside down. All the electrons are going to fall out. AT Sam, for all you AT Atmel Sam fanboys. And oh yeah, there's more production test fixture holes over there. And geez, these components are really placed close to the edge there. Yeah, ask your assembler about that. Normally you want some clearance from the edge, but anyway, no, you can do it. Little ground fingers, are they? Anyway, got some real relays on here. So yeah, here's our DC input. So looks like, do we have, like, there's absolutely no components on the bottom. This heatsink on the bottom here, this all, okay, it's, right, it's screwed into there. Okay, right, so it's coming through. You can see all the thermal vias here. So, yep, they've just got a insulating seal pad under that. So there you go, and we've got it out. Do we have a couple of MOSFETs down there? There you go. They're just little different range current shunt resistors. They're tiny. That looks like a common mode choke. I'm probably not going to try and reverse engineer this thing to tell you what's going on here, but anyway, it looks like it does actually supply the power, just measures, uses some shunt resistors, and basically measures the voltage, is going to be measuring the voltage and current. But anyway, what parts do they use on there? Can we see that? It's an analog devices jobby. Yep, no surprises for finding AD7192, which is a 24-bit Delta Sigma analog front end. It's got like a programmable gain amplifier and multi-channel mux and stuff like that. Looks like maybe a Burr Brown voltage reference there. I don't know why they have a second one, and the second one's not populated, but yeah, anyway, so yeah, just a big, expensive analog devices PGA front end. That's just handling all the external stuff happening here. So, but of course, it's not necessarily the hardware, it's all about the software on something like this. But having said that, the hardware looks gorgeous inside and out. So yeah, thumbs up to that. Did well. Well, yep, you can see how serious they are by looking at the website here, and they have two different versions, Standard and Enterprise. They've given me the license number for the Enterprise. Anyway, it runs on Ubuntu, Windows, and Mac OS for you Mac fanboys. So it looks like a real professional solution here for energy, like product design, energy optimization. So here's the Standard and Enterprise version, you know, battery toolbox, calibration service, the extended tech support training by our engineers. So if you want to, you know, if you've got any issues and you want to be trained by them, get the Enterprise version. And, you know, how much does each one cost? Tell us the price, son. Anyway, apparently Sony use one. So battery battery profiling. Wow, it's got a load. Does it have a load? Got an electronic load, does it? To find the best fit, create discharge profiles. Oh, there you go. It does battery discharge. Wow. It's doing... That's interesting. Why all the squiggles? Why all the wiggle, yeah, on that... because it's something's cycling there. Okay. And battery emulation as well. Wow. Jeez. Yeah, no, this is more than just a, like, power measurement thing. This is doing a lot more. Battery profiles, yeah, for different types of batteries. It looks like maybe, GitHub, it's got GitHubby things. Look, I could probably spend like an hour doing a review of this, like as in an edited hour. It'd take me like days to actually do a proper, does login and book a demo. Where do you get started? How do I buy it? I don't want to book a demo. How do I buy? Standard. Oh, you can buy it on DigiKey. No wuckers. Annual subscription. Oh, for the battery toolbox, all the fancy stuff. But they've put a ton of work. That is a metric crap ton of work to actually develop that sort of stuff. So yeah, you can buy it from seed and all sorts of stuff. So there you go. Let's just assume we're a Yankee Doodle Dandy. 88 in stock. There you go. 580 Yankee bucks. But yeah, 580 bucks. It sounds like a lot, but it's, if you're serious about developing products, it's probably not. It's not a lot of money for what I'm assuming is going to be quite professional software and support for this thing. These guys are serious. Not some Johnny-come-latelys. 575, bit cheaper at sea. Anyway, that's the standard version. So I think the enterprise version means that we have to actually buy, yeah, I think we have to buy the annual subscription, get you the enterprise version, does it? 568 a year. A license for 1 year Otti energy management. I'm sure the standard one comes with you like a one-off. Yeah, it's a one-off thing. But yeah, if you want all the advanced functions and stuff like the battery simulation and things like that, I've got a battery simulator here, and it's thousands of dollars for a battery simulator, like physical hardware simulator. This thing will do it along with their software. So the Otti acts as both a power supply to your Internet of Things device as a current and voltage measurement unit, provides up to 5 volts output at 5 amps. Oh, okay, nice. It runs nanoamp resolution current measurements with a sample rate of 4K sample per second. Of course, you can't get the entire dynamic range from 5 amps to nanoamps, even with the 24-bit Delta Sigma. So it's got to have either auto or manual range, and I don't know if it has auto ranging. Auto ranging can be tricky because it depends on the capacitive load you got in the bypassing and all that sort of stuff. Your product, your micro or whatever it is that's changing states from high current to low current can actually hiccup if you try and auto range, because you've got to auto range that current sense resistor, which is in series with your load, your product under test. And if it suddenly goes from low current, like, you know, you're measuring your nanoamps, your microamps or whatever, and so it's got a high value like a 1K series resistor, and then all of a sudden tries to gulp, you know, pull that power that it needs, like it suddenly jumps up to drawing an amp or two, then it's got to take that from, it obviously can't take that through the 1K current shunt resistor that's currently using. So it needs to take it from the bypass capacitors or the output capacitance of the device like this itself, actually the power supply powering it, before then the system realizes, oh, I'm drawing maximum current, I need to current range back up. It's actually, it's real tricky business to auto range stuff like that, especially if it's constantly changing, or you can, anyway, enough of that. Start measuring, start recorder, analyze, and stuff like that. Right. It's a shame that they didn't like provide me like an example doodaddy product that I could just plug in and would, you know, like cycle through a few currents and things like that. That would have been neat. So yeah, it looks like it's fully programmable. You can use the GPIO via scripting. Yeah, it does scripting. I thought it had to. Yeah, so you can trigger your software, and once again, you could actually program into your product. If you're doing development like this, you know what tool you're using like this, you might actually program in, have a few spare I/O pins on your micro, and then you can program it to output various things or receive inputs from this thing that allow it to like power into states and things like that. In fact, you can even build that into your production. Then build that into the software product and use this device as like a production testing bit of kit where you can tell it, right, I'm gonna, like, you hook up the wires and everything via, you know, either your bed of nails thing or just a manual header or something like that coming from this device, and you can use this as a production test system. Not only does it power your product, but then it can via scripting, I don't know what scripting language anyway, via scripting, you can like make your product change into various modes, and you can measure the power consumption to make sure it's all correct and within spec and all that sort of jazz. So, yep, really, you know, you can probably do some really powerful stuff. There you go, time in milliseconds. Looks like it goes down to the microsecond timing and stuff like that I saw there. Yep, there you go, meters and things like that. Oh, look, I could spend a week playing around with this thing. Oh, wow. This looks really professional. They're ticking all the boxes, I think. And then the battery toolbox. Speaking of ticking all the boxes in your toolbox, here it is. Pick the right battery. DC power supply, feature, profile, and emulator. That's worth its weight in gold. Seriously. If you're developing a product and you're real, you know, an internet, like if you're developing a new smartwatch, fangled smartwatch or something like that, you know, it's critical. You'd spend months just like choosing the best optimum battery and power and solution and stuff like that, just R&D in that, really. So you need something like this. That's okay. Battery emulation. It can act as a battery following a discharge curve. Like, fantastic. That's great. So you can do like low battery discharge testing your product without having to wait weeks to actually discharge like real batteries, or wait months or a year or something like that. If you've got like a real low power little farty novelty gadget or something like that you're developing, then yeah, you don't want to wait a year for your batteries to die to test your thing, or get a clunky power supply and stuff like that. This thing can give you a nice profile. That's nice. Wow. Yep, something like that would be worth your, $500-600 subscription. You don't need, once again, you'd only need that for a year when you're developing your product, and then you might not need it again. I'm liking this. I think you need the Enterprise to get the script in. Oh, Lua, for all you Lua fanboys. There you go. Going wild, I'm sure. I've heard about it. It's all the rage, apparently. I don't know. TCP server. It's got the GitHubs. And once again, the battery profile. Okay, that comes in the Enterprise Edition. You get the battery profile in and stuff like that. Cool. Okay, I'm downloading and installing, and it looks like it's just like a serial port interface. So, whoops, setup failed. That was the Microsofty thing setting up. Launch. Didn't do anything, I swear. I just pressed yes, please install. There you go, there's all the release notes. So, it's been around a while. Yeah, it's been around for, it's been around for 2018. Oh, this is old school. It's been around for a long time, so it should 2017. So it should be 2016. So it should be really polished. Wow. No wuckers. Why can't I close that? Okay, so we can power supply, current, voltage, logs. The thing I don't necessarily like about it is like, why have a DC jack here to power things? I would have liked to have seen like another couple of banana plugs on the back so that I can plug that into my bench power supply. I don't want like a dicky plug pack, a noisy plug pack going into this thing. I want the banana jacks. That would have been better. Anyway, I assume like it's already found it. Supply. Arc. Okay. It's all supply on. Oops, something clicked. All supply off. I can hear the relays clicking. So yeah, it just worked. Just connected. It didn't even have to connect. It just automatically did it. Nice. Okay, the supply comes from the power box. That's our only option. There you go. Main voltage. Oh, I thought they said it went up to 5 volts. Oh, if it comes from internally. Right. No, it's still going to let us do 5 amps, even though we've plugged in zippity-doo-dah from it. So, yep, it's got auto ranging. There you go. Aha. There's auto range. Here you go. Choose if you want the arc to switch automatically between different measurement intervals. When the box is ticked, the higher measurement accuracy interval is used if the current is between 0 and 19 milliamps. However, the arc will not be able to keep constant voltage in this range for voltages above 3.75 in USB, 4.55, supply via the DC plug. So it looks like it can actually power your products through the USB. So that's kind of like in low current mode. So that's really cool. Like if you're working on like low power Internet of Things, smart farting watch or something like that. Great. Excellent. So you don't have to dick around with an external supply. That's neat. Yep. There you go. Anything under 19 milliamps. Nice. That would have been, you can get more out of USB. Oh, would have been nice to have like, 100 milliamps, 200, maybe. Anyway, yeah, you can disable that, and ADC current. There's your external current shunt resistor value. There you go. Nice, down to 1 milliohm. Sweet as. Sense voltage, you can turn on your GPIs, you got logs, you got info, and you can have multiple units, which is handy, I presume. You can have multiple units. Nothing else over here. Yeah, because I'm sure multiple units would show up here. I'd be stunned if they didn't. Right, so overcurrent protection. That's nice. See why it knows that, it should be able to sense that you've plugged in an external voltage in, and it assumes that then you switch over to the 5 amps. It should automatically, but I guess it's automatically current limited to that 19 milliamps anyway if you're powering it. Okay, fine. Forget I said it. All right, so I'm going to set that to 3.3. Doesn't matter what our current limit is. Our cutoff. What's the difference between cutoff and current limit? Oh, it'll physically limit the current, otherwise it'll actually trip. That's nice. All right, got to find something to plug into it. All right, I'm going to assume I'm designing a multimeter, which is nice, you know. I think this draws like a couple of milliamps when it's on. You turn the backlight on, it might draw like 15 milliamps or something like that. Works from 3-volt batteries, so we'll give it a bell. Okay, so I don't want 3.3. I'm going to 3. There you go. I'm going to apply. No, my multimeter's not working. What's up? Have I not switched it on? Power switches. 3 volts. There we go. Turn supply on. Calibration recommended. Warmed up and all that sort of stuff. Nice. So yeah, 24-bit. Here we go. So I'm going to switch it on. And my multimeter, I'll put my multimeter. Well, no, we'll turn this. Use the sleep. Turn the. No, this doesn't have sleep current because it's got a physical. Well, it does. It's got a physical off position. So let's turn it to voltage mode. There you go. My multimeter has switched on. Sweet. And arc main current. I expected like a nice, like I want a readout. I want like a 7-segment display readout. I don't just want a graph. Recording CD. You've got to record it. So there you go. You start. I just like to see a live 7-segment display. That'd be cool. I don't like how it automatically zooms in like that. I think that's a bit how you're doing. It's just in your face. I'd much rather. I know that's the algorithm, but so it's detected the minimum and maximum current peaks. I know what they're doing here. They've detected that, but I would like then just double the range or something, triple the range, 5 times the range, just so that you get like a. I don't want to see all this. Like these are obviously these are individual bits. Obviously, like we're so zoomed in, like we're so down in the resolution that these are individual bits. And I don't like that I'm just bombarded with that. But anyway, after having said all that, it's done that down here. Oh, right. No, look, it's got larger peaks. Oh, it's zoomed. Is this a zoomed in version of down here? So they've done what I was thinking down here. So look, it's taking gulps of current, like every... Like what? 5 seconds? Why is it every 5 seconds it's taking that? I'm gonna press a button, see what happens. There we go. Whoa, look at that. That was the buzzer. So there you go. 7.5 milliamps for a beep there. Got some undershoot, right? Because probably the long leads on this, right? We're not probing this thing. We're not probing this thing properly. We're getting massive undershoots on that. Of course, it's not drawing negative current, right? It's dropping below. Okay, so the base, looks like the base current here. Can I stop this? How do you stop? Okay, so why is it showing 10? Like I'm powering this internally. Why is it showing a negative current? It should know. It should get the polarity correct. So that's a bit weird. I'm not sure. Maybe it'll come to me why it's doing that. But at the moment, like it's showing minimum. Right? I'm looking at this one down here, right? Minimum. Where's the, like, it should show like a cursor value. Should show a cursor value, but it's not. It's just showing, can I like drag? Yeah, I can drag. Nice. Look at that. Yep. That's great. That just worked exactly as I expected. So if you wanted like the average energy, it's got nanowatt hours in there, for inside that, then that's really quite nice. So once over a time period, 6.3 microwatt hours over that time period. If I use my mousey wheel, that zooms in and out. That's really quite nice. How do I drag? Do I use I expected to use my right button there, right mouse button, but all I'm getting is fit height, fit width, save as PNG, very nice. Down sample, ooh, interesting. Oh, that's nice. That's useful. No, I'd like to be able to use my mouse. Anyway, you just drag it like, maybe there's some way to, maybe I can hold down a button and no. Anyway, there you go. So if you want the current from, there to there, or energy from there to there, 7 microwatt hours, that's really quite nice. Just, little things really I'm just nitpicking about is that, like it shows minimum, like at that point, there should only be one value. At that one point, there's no such thing as a minimum, maximum, average, because we're only one sample point, right? So it should give us the cursor value there. So anyway, my multimeter is drawing, there you go, 2.2 milliamps, like 2.3 milliamps on average. And then when you include, you know, if you include that over the range, what is that, 3.3 milliamps if you can choose that time period, but over that time period there, the average is only 2.43. So you can see that I'm getting, like, you know, here, I can slide the window. Nice. Okay, yeah, I'm liking this. Sorry. Anyway, so yeah, you can see that, like, the average over here is 2.3, and you can see how, you know, having the occasional current pulse like that, even though it goes up to like 7-8 milliamps or whatever it is, then it's, you know, it doesn't add much to your average current consumption there, because it's just a brief pulse. It's divided by the time. So, you know, anyway, that's really cool. Whereas if I did a tiny little window there, you'll find that our average is gone to 5.1. Funny that, because we're averaging over a different time period, but that's really quite cool. I like that. So there you go. That's a yeah, I just like, yeah, like, new recording. We can overlay with the different currents and things like that. So fit width. Okay, so we can fit. Oh, okay, because it's got to catch up because we've got the other window. Yeah, okay. No worries. Go to time. Anyway, we can switch our grid off and on. That's good. Oh, silly me. This is ADC current. This is ADC current. This comes from our analog to digital, our external input there, which we're not using. We've got nothing connected. That's why it's just flapping around in the breeze with a couple of bits. Okay, right. See, that wasn't obvious. The main current is the banana jacks on the front. These banana jacks powering our product, that's what we're looking at. That's our main current. This thing here is the ADC current. That's completely, it's obvious. People were probably screaming at me. Anyway, I'm trying to yap at the same time. It's hard. It's hard being a video blogger, you know? So yeah, even if I go like that, boom, 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 our top one doesn't change because we're doing zippity-doo-dah. We're not doing that at all. I would have put that on top. Like, I would have had, actually by default, when this thing opens, I would have not had the ADC current displayed at all, really. Anyway, and I like that it doesn't bother showing voltage because it's just constant voltage. It doesn't bother with any of that junk. Well, you could argue that you could, it's fine. It's just focusing. It's giving you the two current waveforms. I know why they do it, because they have two measurement paths. They have one as the BNC input, one as the pin header input for the ADC. So yeah, like they should have called it like ADC current. I don't know, maybe external current, but they're both external. But anyway, I would have put the main one on top. There you go. That's groovy. So can we like clear all that? So we can nuke that, right? We can delete it. We can stop that, and we can nuke it. So here we go. Because we've got auto ranging set, it's 0 to 1 amp here, and if we simply switch it on like that, then it's automatically magically auto ranged down here. So yeah, it looks like our meter is just periodically taking, like in the scaling could have been like, where's the 0 here? Like the scaling could have been better there. I'm not sure. Like, show me the 0. Well, no, you don't have to, I guess, because then you expand the waveform. But anyway, yeah, the scaling could have been a bit better there. That's all, minor gripe. And then it'll, of course, it's not auto ranging when I press a button. That's just, you know, it's auto scaling, but it's not physically changing the range in the hardware itself. So, yeah, that's groovy. What if I turn the backlight on? Haha, there we go. And so our average current, you see how it spiked up to 60 odd mil. Oh, it's only supposed to provide 19. So there you go. Did it, like, why? Why is that, you know, why has it let us do that, I wonder? Anyway, and then we can move our window over to here. And we can zoom into here. Aha, you can see the step over there. There you go. Gotcha. There's our backlight. Look, it's done the same thing there, and then boom, on. Oh, was that the buzzer? No, that might be the buzzer doing something. Anyway, we do have a huge spike up there, which is presumably beyond the range of this thing. It's going up, like it's almost like it's clipped up the top there. It's only supposed to be 19 milliamp range. But see, but you can see that this is a very useful tool right off the bat. Like, we're not even getting into all the bells and whistles of this thing, all the scripting and doing everything else, all the goodness that you can do with this sort of thing. But there you go. It's got higher noise up here, which, oh, that'd be the backlight. That'd be the, no, it's a LED. This just doesn't have a backlight inverter. I was going to say it's not a backlight inverter generating noise, but this has a, this is like noisier up here than it is down here. See that? I wonder why. That's interesting. There you go. Anyway, let's turn it off. Oh, I need to fit width. There we go. Once again, yeah, look, it's dropped down below negative there. So that is a function of your probing. Whoops. There we go. Yep, got a real brief period there of where it's dropping negative, which is not. Oh, and no, this could measure positive and negative currents, can't it? I assume it's bipolar? No, it's not, because we're the single supply. So it shouldn't be bipolar. So it's going negative there. So, yeah. Probing is a big thing too. There you go. That's cool. If we stop that, what can we do with that? Offset, we can jump to an offset. And I think we can export that file. We can save project. Yep, export CSV. Nice. Offset by selection. Oh, here we go. We can disable, silly me, look, we can disable our ADC current down there. There you go. Fit selection. Can we play? Can we like set like an auto scroll playback? Show statistics for all recordings. Oh, okay. There you go. We can turn that off and on. Oh, it overlays them on the graph. Okay, that's cool. Meters. Aha! Here you go. Our meters are down there. That they weren't there before, were they? No. Should switch those on by default. I don't know why you would not have those on. Why wouldn't you have those on? There you go. That's your live update reading down there. Yep, they definitely should have had that. It's got internal temperature sensor too. That'd just be coming from the SAM die. Get it for free. So that's cool. I haven't even gotten to. Look, as I said, I could spend ages actually not reviewing this. Ages actually reviewing this, but the software looks quite polished, very professional, and like we haven't even gotten into the really cool stuff that you'll admittedly pay a fair bit of coin for, but I suspect worth every cent. You're doing battery simulation and stuff like that. That'd be absolutely fantastic. They like separate tools, I assume, because like we've just got logs. What's this? Why do we set our baud rate for a UART? Oh, why is that under logs? Anyway, yeah, this is like a professional power measurement tool. They've done well here. You can see the spit and polish in this, I think. That's been, what, is this 3-4 years old? 3-4 years in the making or something like that. They're continually releasing new firmware and new versions of the software, and it shows it is actually quite polished and pretty much works the way I expected. Just like little minor things perhaps, but yeah, that's it. It's really quite jazzy. So yeah, that's very nice. Thumbs up to that Quitech. What is it? The Otti. So yeah, I've got a 2-week trial license activation key of the Enterprise version. So, you know, if somebody does want me to, well, I might save it. Maybe I've got like a real app, you know, I'm going to need it for some application or something like that. So, yeah, that could be really useful. I do have a battery simulator here, but it's a big clunky, what is it? It's an old clunky Keithley 2302 for those playing along at home. I don't think I've done a video on that. Anyway, I do have a battery sim. I haven't done a teardown on that battery simulator. So, yeah, that's very cool. That if you're developing any sort of product that where battery, you know, measure like power consumption is important and stuff like that, seriously, have a look at this tool. Maybe like you can probably download the software. Is there like a demo mode or something like that? But anyway, you've seen what it can do. It does all the basic stuff, and I have no doubt that it does all the advanced scripting stuff and things like that as well. Awesome. Thanks, Quitech. Nicholas Pissarro, thank you very much. Nicholas is in San Francisco. Hi to all my San Franciscan viewers. Hi Dave, I made these after getting burned a couple of times trying to program an Arduino, etc. with a spare USB micro cable that turned out only have power and not data lines. Yeah, I've been caught by that many times. I've been doing a video, whatever, I search around for a random USB cable to go in, and I wonder why the product's not working. It's because, yeah, it's only like a power cable. It doesn't have the data lines. It's crazy, Huxley. I reckon fail for those USB cables that don't have data lines. Yep. Well done, mate. Awesome. Yeah, nothing worse than those. They're really annoying. I also learned that data lines are necessary for negotiating large currents. Yes, they are. So is this it's just like a breakouty thing with various resistor values. Cool. We'll take a look. These are handy. Always have, like, I lost count of the number of times I've used. Oh, that one's got a battery on the back. That's interesting. Why do you need a battery? You can power it from the USB itself. Next package. Oh. So this is Nick's little doodad. Aha! It actually, I figured that's why it needs a battery. You plug your cable in, like it loops through and tests it. Great Twitter handle, by the way. High energy beams, absolutely fantastic. You can get on the Tindie store down there and check it out. Isn't it cute? Oops, upside down. All the electrons going to fall out. Is it me or is it just USB? Nice. And of course, it's just going to check out all of the data cables. That's USB micro cable and human sanity tester. That's worth every cent. Love it. Link down below. Good on you, Nick. It is from Mark Coldwell. Thank you very much. Another one from the United States of America. If you couldn't tell from the United States postal colours there. No, I don't think you'll get that, Hux. You want me to slice it open? Yep, slice it open. This one's going to be a bit tricky. Okay.
Or you could just go down, up. You could have them down.
I could have gone the other way, yeah? What have we got? Obviously, it's not a product. Oh, what have we got?
Money.
We got... Oh, no. Really? Really?
And also...
We're getting political here on the EEVblog. Don't blame me. Blame my viewers. I do open everything on camera. There we go. We got Trump bucks.
Totally a fail.
Totally a fail. Give it a fail, Hux. Trump bucks. Trump 2020, Huxley says it's a fail. There we go. That's... Wow. Is that a fail too, Hux? Yep.
Another fail.
Another fail, you think? Yep. But he will win. It's practically guaranteed. Practically guaranteed, whether you like it or not. Yep. There you go. The in God we trust on the currency. Only in America. All right, Hux. Thanks for joining us on the Mailbag. Say, catch you next time.
Catch you next time.
Well done, Hux. Oh, you're tired now, are you?
Yes.
Yeah. That was a lot of effort opening those packages, mate.
Sure is.